These notes are on compound inequalities. So compound inequality means more than one inequality that you're solving at the same time, and they're connected with and or. So compound is the same as if you have like a compound word. So like bookkeeper is a compound word because it's two words to form one word. So a compound inequality are two or more inequalities, and we'll stick to two in algebra too, but if you move up in math, you might have more. Two or more inequalities connected with and or an or. So connected with the word and or the word or. And we're going to talk about the difference between ands and ors. Connected with and or. All right, so for instance, it might look like 3x plus 6, I'm just making something up, greater than 5, 2x minus 9, less than 3, something like that. And you'll see like an or there, or you might have an and in there. Okay, and there's also something called double inequality, and we'll talk about that in a little bit as well. So let's talk about ands first. So if you have an and in between your inequalities, your solution is only true if both inequalities are true. So if I say, and it's called the intersection. So if you have, it's kind of like this. So here's people who love cats, people who love dogs, and then there's people like me who love cats and dogs. So it's where they overlap. Okay, it's called the intersection. So it's going to be where your two graphs overlap. And it's also like, if I say, hey, I live at the corner of 17 and Goosley Road, where our school is, I'm on that corner. Okay, so it's where both things are true. Okay, so the way we're going to solve these, we're going to solve one inequality and you solve the other. And where the two graphs overlap is going to be where your solution is. And we're going to write our answers in what's called interval notation. So let's do an example of an and. Oops, I accidentally hit the highlighter, so let me erase that real quick. And here we go. All right, so 10. I still have the highlighter selected. All right, let's try that again. So 10 minus 2p less than 12 and 7p less than or equal to 4p plus 9. So what I want are all the possible solutions that work in both inequalities. So if I substitute in the first inequality, I would get a true statement, and when I substitute in the second inequality, I would get a true statement. So we're going to do this, we're going to solve each one. So let me solve this one. So I'm going to subtract 10 first. I get negative 2p, because remember this minus sign becomes a negative, is less than or equal to negative 2. Divide by a negative 2. Don't forget, even with these inequalities, when I divide by a negative, I'm going to switch the direction of the inequality sign. So don't forget that. That's important. All right, now let's solve the other one. I'm going to subtract the 4p. All right, and I get 3p. 7 minus 4p is 3p. These cancel. That was the point of me subtracting the 4p, was to get rid of it. Remember, you want your variables on the same side. And especially with inequalities, I recommend moving to the left because we tend to write our inequalities that way. Variable less than or equal to, greater than or equal to the other number. Divide by 3, and I get p is less than or equal to 3. So my solution is all the numbers that are greater than or equal to negative 1 and all the numbers that are less than or equal to 3. So both things have to be true. So even though 4 is bigger than negative 1, it's not less than 3. So it's not a solution to this. So let me show you how you would graph this. And don't write the graph until I say, hey, graph complete. Okay, so here's the number line. And number 1 is, negative 1 is here, 3 is somewhere here, and there's numbers in between. Remember for, and we'll put this on the side here, so you might want to write this down in case you don't remember. Less than or equal to, greater than or, whoops. Don't forget, greater than or equal to and less than or equal to are brackets. And parentheses, so greater than is a bracket going this way, less, greater than is a bracket going this way, less than this way. Remember that if it's just greater than, we're going to use a parenthesis. If it's just less than, we're going to use a parenthesis going this way. Okay, so let's graph it. So let's look at this. So we have p greater than or equal to negative 1. So, and we're going to complete the graph in a second. Again, you're not writing this quite yet. I would write that purpley stuff I wrote up here. All right, so p is greater than or equal to negative 1. So greater than or equal to negative 1 would go this way forever. P less than or equal to negative, or 3 would go this way. So my solution, what I'm actually going to graph, is where they overlap. So it starts at negative 1, it goes to 3, and it's everything in between. Okay, so it's everything in between there. So when I write this in interval notation, it starts at negative 1, and it goes to 3. This is the solution and written in interval notation. Okay, and that's what we're looking for. So the and is where they overlap. So what's in red here is the graph you should put down. Okay, you should put that graph down. This is your interval notation. And that's how we're going to write our solutions. So that's saying all my negative 1's the solution, 3 is the solution, and every number in between is. So ands tend to look like that in interval notation, by the way. All right, this is what they're going to look like. It's in between these two numbers, and that's how you're going to write it. So again, and is where your two graphs overlap. Solve the one inequality, solve the other, figure out where they overlap, and that is your solution. Make sure you write your answer in interval notation. Double inequalities. So someone who was kind of lazy, which most mathematicians are, said, all right, let's have an inequality that looks like this. So don't write this down quite yet. And then I say, and 3x plus 6 is greater than 9. So let's say both of those are true. And they said, hey, well, this expression and this expression are the same. So let's write this in a shorthand version. So, okay, so 3x plus 6 is greater than 9. All right, 3x plus 6 is greater. So for some reason my pen doesn't want to write greater than 9. And they said, all right, we don't need to worry about that. So there you go, there's a double inequality. What's nice about double inequalities, first of all, they can be ands or ors, but for algebra 2, they're going to be just ands. When you finish, it really has your interval waiting there for you. Now the trick is to isolate the variable in the middle of a double inequality. You must perform the operations in all three parts. So if I subtract 6 to get rid of it, I got to subtract 6 here and here. All right, and then I get 3x plus, whoops, nope, the 6 is gone, is less than 15 minus 6 is 9. That took me a second, guys. Well, in my notes, I have 15 minus 6 is 5, so that's why I was like, that's not right. All right, now I'm going to divide by 3 to get rid of that. If I divide by negative, I would switch both inequality signs. So now I get 1 is less than x which is less than or equal to 3. By the way, that would be set notation if you're looking at that. But we want to write interval notation. So I'm going to put this on my number line. All right. I got 1 and 3, and x is less than or equal to 3. So less than or equal to would be a bracket, but it's greater than 1, so that would be a parentheses, and I missed that completely. And that's all the numbers in between. So in interval notation, that'd be 1, 3. Okay, I don't know, my cat's yelling at me. All right, so that's a double inequality. So you solve the middle and the ends. All right, so you have to do all 3 parts. But what's nice about it, once you finish it, it's pretty much ready for you to go to graphing. So it says x is less than one thing, it's greater than the other. You graph it and you write that in interval notation. So now we're going to talk about ORs. So let's relate this to the cat scenario we talked about. So we have people who like cats, people who like dogs. Remember when we said and, it was these are people who like cats and dogs. But I say, hey, I want to talk to everybody if you like a cat or you like a dog. So here's people that like cats. Here's people that like dogs. And it's everything. Okay? It's everything. It's this or it's even this. So if I say I live on 17 or Goosely, it could be all of 17 that goes from like Florida to Maine, or that little bit of Goosely. Okay, so it's everything. And ORs tend to look like this. I go this way or I go that way, and you can have brackets or parentheses, but that's what they tend to look like. So we're going to solve our 2 inequalities, and wherever we graph is a part of the solution. It can be this or it can be this. All right, it doesn't have to be both. It can be this or that. This or that. You can get with this or you can get with that. And this is where it's at. Okay. So let's solve it. So I'm going to subtract 8. So I'm solving this inequality. I'm going to subtract 8. I get 3x, that is not an x, but this is greater than -6. Divide by 3. X is greater than -2. So that's part of the solution. On this one, I want my variables on the same side. So I'm going to add x from here to here. It's a minus x, so to get rid of it, I add it. I have 2 x's now, plus 12 is less than 2. Now I'm going to subtract 12 and divide by 2. Subtract 12. 2x is less than -10. Divide by 2. Dividing by a positive, so I don't need to switch the sign. All right, so now let's put that on a number line. So on the number line, -5 would be here. -2 would be here. I almost put it on the other side, but that would be wrong. So x is greater than -2, parentheses, because it's not greater than or equal to, going that way. Or it can also be less than -5. So it's going to go this way. So let's write that in interval notation. So I start at -infinity. Remember, there's always a parenthesis next to -infinity, and that's right here. So -infinity over here. It goes forever. And then it goes to 5. And then I start at -2, and I go to positive infinity. Remember, positive infinity is up here. Now, we want to join these two together as one solution, so we put in what's called the union symbol. Okay, that's a symbol for a union. All right, that is how you're going to write it. That's how we say or in math, with that union symbol. So my solutions are -infinity, -5, or union symbol, -to infinity. Okay, so again, and it's going to go from number to number because it's where they overlap. Same thing with the double inequality when it comes to algebra 2. Ors can go one way or the other, and we put a union symbol in between to join it because it can be this or it can be this. Okay, it doesn't have to be both.